Hey everyone, welcome to the AMA. Oh, I think we've got some audio. All right, so we will work on that in just a sec. Hey, we're live. Woo!
Yay!
So if you've never been to Mini AMA before, welcome. My name is Maria Plessel. I'm the executive director of Mini Star. We're the nonprofit in the Minnesota community that brings together the technology ecosystem and really anyone that considers themselves a tech enthusiast through meaningful connection. So one of the ways that we do that is twice a month we run Mini AMA. And that's what this is. So it's an opportunity to kind of sit down. It's an interactive educational series. We're joined by subject matter experts to answer your questions and to learn and get to know one another. So we're really, really excited to have back in action. We have Nick and Thong that are back here going to be talking about AR and VR. This time we're talking about designing the future of experience. So really taking a look at the process of design, development, and deployment on these new platforms. And so we're really pumped about that. A couple housekeeping items. If you've never been on Crowdcast before, we are going to, like I said, be taking your questions live. So there's two avenues to do that. One is right in the chat, and one is the Ask a Question feature that is below. Both of those, we will find you. We will get those questions answered in real time. But for right now, we want to make sure that you can hear us. So let us know. Drop your name in the chat. Who are you? Hey, Thad. How's it going?
Hey, it's Thad.
Yeah, introduce yourselves. We want to know who's here. Hey, Martin. All right, perfect. Glad you can hear us. Another veteran of the VR AR world. Oh, hey, Brandon. Hello from Florida. You got the weather on us. You got us beat there. Mr. Gav, Willie. Hey, Greg.
Awesome. Oh my God, it's real people out there.
Woohoo! All right. Well, like I said, we're going to get started here pretty quick. Nick, I'm just going to test your sound and just make sure we're not getting that same feedback. Just one sec. Testing.
Okay.
Testing.
Better. I think I had two browsers open.
It'll get you every time. It'll get you every time. All right. Perfect. Hey, hit that. All right. Tim, welcome. All right, I'm going to let our panelists introduce themselves, and we are going to dive into some really, really exciting playing actually with some VR AR tech. So, Nick, why don't you start taking it away?
All right, great. Thanks, Maria. I really appreciate you having us here and all the awesome work that Mini Star does in the community. We're excited to be here today to talk about AR and VR. So I do consulting in the mixed reality space. And I've been in the tech community, entrepreneurial ecosystem for quite a while. I'm really bullish on the whole AR, VR, or mixed reality space in general, with everything that's been going on lately between the pandemic and all of the industrial applications, which is what we're here to talk about a bit today. I'll let Thong introduce himself.
Hey guys, my name is Thong Nguyen. I'm the founder and CEO of Rumera. Like Nick, I've been kind of in the tech and entrepreneurship space here in the Twin Cities for some time now. And I've actually been working on VR since I think late 2015. So kind of riding that wave up and then, through that trough between 2017 and 2018, and then kind of seeing where VR and AR are at today. Really interesting journey. So our mission at Rumera is to help people see and test the future. Historically, we've been really focused on B2B and helping organizational leaders kind of design future experiences. Heading into 2021, we see a lot of opportunities around the consumer space. So as headsets become more accessible to people, I think there's a lot of interesting design challenges and opportunities that VR and AR can help with.
For sure. Awesome. So yeah, what we want to do here is to kind of talk about some big picture, but then get into a bit of kind of storytelling around the design, development, and deployment. And I'm going to kick it off for, I'm sure a lot of folks on the call, have experience in the AR and VR space, but I just kind of bumped it across a website earlier today, and I wanted to bring it up as just kind of a way to kick off the conversation, really about kind of this continuum of AR and VR and how it's expanding across different applications. So let me pull that up really quick. All right, you guys got my screen?
Got it.
Okay, great. So this site just launched. It's called Metaverse. No, association, no plugs or anything like that. But I thought they had some great, really quick video shots here to talk about, how AR and VR are expanding into a lot of different categories. So they have an instance here of retail, and this is becoming more and more used. I mean, if you go on your Amazon app right now for a lot of products, you can see something in your house. For fashion design, you can see a watch on your arm. You can check out a pair of shoes on your feet without leaving your couch. So there's a lot of stuff in retail. I think there's a lot of opportunities and potential to really kind of change e-commerce and retail moving forward. And so they've got some kind of examples here. The future of training, right, where you have these big models built out, and you can now do some training. I saw another one with complex. The aerospace industry is very heavy into this training pilots. They've been doing that for many, many years. But we're going to start to, or we're going to continue to see the expansion of these 3D models in kind of a training context. And the reason I wanted to bring this up, specifically, is that if you look at this video is comprised of a bunch of 3D models. And when we're talking about design, development, and deployment inside of this AR, VR ecosystem, these 3D files might be used in a training program, once everything is done and built. But when we're talking about manufacturing, these design files are created at the very beginning. And so we have kind of this concept, started. If we look at the retail models up here, we think about what is a big component of virtual reality or augmented reality is the models. So you have the application design that's going to deliver the models. You have a cloud architecture that is going to store models. But a really big component of what we're talking about with all of this is the actual models themselves. And so starting out, like the Apple Watch, they're designing that from day one. You might see it in Apple, e-commerce site on your wrist. But they designed that, a couple of years before you see it. So just to understand kind of that continuum, setting it up for, where we're seeing it in retail or training programs. And so what we wanted to kind of walk through starting out up here is what we have is this kind of application design. And I'll actually take a step back really quick because there's a bit of an overlap here with kind of the general enterprise VR AR continuum. We talked about this a little bit in our last session. What we're going to focus on specifically in this session is, we talked about retail where it's going to have, starting with design, the actual building, and then the deployment of some form or another. We're going to start out this conversation because of my experience and Thong's experience in really the enterprise area of design and build for real estate. And if we look at this continuum, up top, we've got design, build, and deployment. And so when we're thinking about those 3D models, a lot of those 3D models are started early on in the concept phase. So people are using modeling applications to design maybe what an entire property might look like. If in St. Paul, we've got like the Ford site project, guaranteed that people started out with a lot of architecture and design and concepting in 3D applications, and then using that to iterate for what it's going to look like. To expand on that, then you get into more of the complex architecture and design testing. That is the area that Thong's going to walk us through in a few minutes here. And then eventually those files get handed off to a general contractor. They start with the architectural design files, and then they're going to use them for various things throughout. And I'll walk through a little bit of what those models look like and how it's implemented. You can see in here, they're used for coordination meetings to make sure that all of the different subcontractors all know what they're doing and when, and trying to identify any issues. During that phase, you have a further build out of that model design and kind of the iteration, that comes through with that. And then, all the way through framing, plumbing, electrical, QC to project completion. We'll talk a little bit more about that later.
Hey, Nick, just one quick call out for the audience too. Something you'll see in our presentation today is there's a little bit of a slant here towards VR and AR for physical design. What I do want to call out is that some of the VR work that's happening and AR work that's happening actually goes beyond that too, like into things like training and soft skills. There's a lot of work around DEI, diversity and inclusion. And there's a lot of other applications beyond what we're going to be focusing on today, just so the audience is aware.
Yeah, absolutely. No, I mean, like the metaverse, kind of this new 3D world that's being built right now is another interesting example of that, where it has nothing to do with physical. But that's a great point. So as I was building that slide out, I kind of looked at, in how we're going to talk about this today, is design, build, and deployment for AR or VR applications. So you need to, obviously you're designing an application, starting with some concepts, doing some design architecture, technical architecture, and then you're going to be using that for design testing, and then integrating a development team. You build iteratively, you have QC, and then ultimately you have some sort of a project completion and deployment. So kind of this is a framework a bit for how each of us are going to talk about our, kind of contextual areas inside of this enterprise VR AR continuum. And with that, I am going to hand it over to Thong to get started talking specifically about that upfront design phase.
Awesome. Thank you, Nick. So I guess maybe to step back a little bit, there's a lot of buzz today about VR and AR in gaming. Nick and I talked about that at our last session. What I've been focused on is VR actually within the design phase and specifically within organizations. And one of the challenges that you see is that design is really hard, right? There's a smaller group of people who potentially have a vision of what the future looks like in their mind. But as you know, anytime you're doing a big effort, there's a lot of people involved. So one of the major challenges you face is, number one, how do you get everybody on board with what's in your head? And then number two, at the end of the day, what really matters is how customers respond to this. And sometimes in the design process, if you're not testing early on, you don't actually get validation that your concepts actually work until way too late. So at that point in time, it's really expensive to make changes. You can't pull them back. And then you end up making a lot of workflow changes that have implications and cost ramifications down the road. The other challenge too is that we're in an era where, innovation isn't just about repeating what's happened in the past. The future is really about iterating quickly and making sure that you can make incremental changes or revolutionary changes that when they land, you have a better chance of success. And so what VR enables you to do is actually try those things out before, and then be able to fix and adjust as you go along. So what we've seen is that it's really impacted the design process. And rather than just talk about it theoretically, I think we have some examples today to show you what that's about. So I'm curious, a poll of the audience, how many of you guys have had a Krispy Kreme donut in the past, 5 years? Did you go to Iowa, Nick? No. So, hey, Mike's had one. That's awesome. So the last time Minnesota had a Krispy Kreme was 2002. And what you may not know is that store in Maple Grove actually struck the all-time record for all Krispy Kremes worldwide on opening week. So I think it was like 500 million. And so there's something about Krispy Kreme in Minnesota. And yet today in 2021, we have none, which is absolutely wrong. And to that point, right, in 2019, there was this guy who had to make drives down to Iowa to buy Krispy Kremes And there's a whole story around that you're probably aware of. But he was bringing donuts back 270 miles, like truckloads of donuts back, and people were buying them off of them. So anyways, note to Krispy Kreme, you should come to Minnesota. So today, they actually have about 1,400 shops in 35 countries. And the reason I share this with you is that we did a project a while back with Krispy Kreme as they were designing out a brand new store in Times Square. So the context there is most of their stores actually look the same. They're similar models, repeated and built out. So there's a scalability factor. But when you're building in Times Square, the context is very, very different. Let me see if I can switch screens here real quick. Give me just a second. Helpful to see. Maybe you can fill a little bit in.
Sure. So yeah, what Thong is going to be going through is a little bit about that experience design, up front, and you'll all have to kind of bear with us here because live demoing VR and AR can be very tricky. So there's a high potential of having some sort of issues one way or the other here.
Yes, and if it makes it even better, so the screen is mirrored for me right now, so I'm navigating all this backwards, just so you're aware. Even better. So if you didn't know, Krispy Kreme is headquartered in North Carolina, and the store, obviously, that they're building is in Manhattan. So there's a distance factor there. So I'm going to see if I can zoom in here. Oh, yeah. Driving backwards on Google Maps. Amazing.
That is asking in the chat. So where's the Krispy Kreme VR for the donut?
Well, we'll find out. So I'm gonna drive you up here. Oh my gosh, this was so not designed to go backwards, guys. So what I wanted you to show is just the context of where this Krispy Kreme is located, and I'm gonna try to zoom in. Oh, there we go. So this is Midtown Manhattan. And the Krispy Kreme is located actually just down the street from Times Square. So that is Times Square, and I'm going to try to zoom in. This is not going very well. Ha! All right, so I think I'm at the intersection here. You know what? I'm gonna go over to the other computer so I can actually see what I'm doing here in real time instead of trying to drive backwards. Here we go. So this is Midtown Manhattan, and Times Square is right here. And you can see, so this is where the ball drops. There we go. That's where the ball drops. So you're probably familiar with that intersection. Where the Krispy Kreme is actually located is right down the street, right here. So you can see that this photo is pre-construction. So they were just starting construction at this point. And this is sometime in 2019. And so one of the major design challenges is pre-COVID, this intersection was actually receiving about 390,000 pedestrians in the average day. How do you handle that type of traffic in a store? And that's a challenge that they hadn't had to solve before, and one that VR was actually able to help with. So with that said, I'm going to pop into VR. Give me just a second here.
So while he's pulling that up, I can set a little bit more context. The great thing about these VR experiences is you might have to set up a warehouse somewhere and try to design all of this stuff in physical reality. But now with VR, we can create any environment that we want. We can create these walkthroughs. So whether it's a Krispy Kreme or you're designing anything in retail or big office buildings, and you're trying to sell it to a group of investors that are going to build a new skyrise downtown, Now we have these tools that are much more effective and efficient at allowing us to bring people into the future or the potential for what they see. And that's a lot of what Thong is showing here.
Can you guys see okay? Is
Yep.
this coming through?
Yep.
Awesome. Rumera, calibrate. All right, so I'm going to give you an embodied view to just give you an idea of the scale. So I showed you on Google Earth what that looks like in terms of the intersection. So this, looking down that way, is Broadway, and this, I believe, is 48th Avenue. And so thinking about that space, there was a lot of thought put into the approach angle and where you're coming from. What do you see, and what are the sight lines as you go along? And those are really hard to actually test out when you're just looking at a floor plan. A lot of the time at this early stage of the design process, you're looking at inspirational documents, you're looking at floor plans, you're looking at materials. But the challenge is you have to put all that together in your head. And as you know, some people are good at that and some people aren't. And at the end of the day, all of those design decisions have to come together in a way that's cohesive to the actual consumer experience. So I'm just going to give you a little bit of a walkthrough tour and to give you an idea of how some of this came together. Before I actually go into the store, I want to call out too that one of the design decisions they made was around this space here, and it's just the walk up to go. And I have to say there's at least a dozen iterations that they went through to design this, including like how big the window is, how high it is, how people can reach across, where this the height of this table is. And being able to do this in a model really helped them iterate through that physically, so without just making theoretical judgments. I'm going to head back around. So when you walk into this store, there was a lot of thought put into, again, the sight lines and what you see as you walk into the store. And like I mentioned before, they've never done a store like this. This was a 4,500 square foot store with a lot of new elements. Including this table here, the level of merchandise that they put into the store. Romero, release. I'm going to give you a first-person view here so you can say. Thinking about where people would stand, where they would lounge. And something to call out too is when they first started this design, COVID was not in play. And so VR helped them throughout the COVID process as well to figure out, well, before the store is built, where do people actually stand? Where do queues actually form? Something else to call out too is the integration of digital. And you can kind of see there's animation going on in the table here. There's a lot of elements in the store that were digitally integrated, including the checkout area here, as well as some of the screens and the interactive displays. One of the biggest features of this store, again, is the waiting experience. And so all the things you can look at as you go along, you can really start to understand how donuts are made as part of the Krispy Kreme brand. And then you can see the donuts actually being made here. Some quick facts. So this store produces about 4,500 donuts a day. And it is the biggest producing store in the world. And I think one other fact was they have 16 varieties, including the original glazed, which was made more than 80 years ago. So they actually have a special thing that comes off the line too called the candy apple one, which is specific to New York. So you can see here they did a lot of digital work with projectors, actually casting light onto the donuts and then the backsplash. And then you can kind of see it here, but there's also some displays happening that are projected onto the original glaze. So again, when they received the pitch for a lot of this stuff, it was hard to kind of imagine, right? And so what VR helped them do was walk all the executives through so that they could actually see in reality what that would look like.
So Tom,
yeah.
How did you build this this world? Maybe we can talk a little bit about the design and development aspects of this, right? You got the models, and then this was built on, I believe, a custom platform, Rumera. Is that right?
Yeah. So our platform, Rumera, is actually based off of Unity, but we've done a lot of work around modularizing these environments and being able to distribute them remotely. So something to call out is a model is great when a person can look at it, but it's much better than when multiple people can come together. And so I called out to you, right? So their headquarters is in North Carolina. Some of the teams were actually located in New York. Some of the teams were located elsewhere, and they actually had executives from all over the world that were able to visit this environment without actually going anywhere at the same time. And so they would actually hold meetings in this space before it was built, which is pretty interesting when you think about it.
Right. Yeah. And so the one thing that definitely is important is, the model is a massive amount of the work. Could you boil it down to like percentage wise, how much of, this project was in the development of the model?
I would say that it was really iterative, and a majority of the process was the model itself.
Sure.
And the challenge, right, is in this stage of the design phase, you don't have BIM files for everything because not everything is figured out.
Right.
And so as this store was being built, there were sections that had BIM. And for reference, BIM stands for Building Information Model. Those are the files that construction teams use that are digital, that represent the physical space. A lot of the time, those didn't exist, right? And the other thing that BIM doesn't tell you is what some of the materials look like, right? So some of these surfaces that were used, there was some creative interpretation that was needed there.
Sure.
The other thing that BIM doesn't tell you is where's everybody going to go? And so when you start to think about space and checkout, something you can do in this model that you can't do elsewhere is start to operationalize and plan out where people are going to stand. And when you have a space that's this packed, you need to figure that out beforehand. Otherwise, you're going to get traffic jams everywhere in the store.
Sure.
I'm going to put him there for now.
We did have a question come through.
Yeah.
So Bob had mentioned earlier about kind of when the head changes, it can come across a little bit jerky. And Greg is wondering, is it possible to build into the experience views that ease in and ease out of head changes, sort of like the VR equivalent of a Steadicam?
Yes, and we have that built into our platform. I apologize because my head is not a great camera for everybody else. But something that we actually added in the software was the ability to just do a first-person view controlled by a keyboard. And that's actually eased into positions. And I won't show you guys that today, but that third-person view was an example of something like that. So if I go back to that, Rumera, calibrate. Rumera, calibrate. Right. And so views like this start to be a little bit easier for people to follow because it's not quite as dizzying as far as perspective goes.
And Thong, is this, are you streaming this content? Is it stored locally on the headset?
No, this is actually stored on the cloud. So
okay.
Yeah, our platform allows teams to do this securely as well. So
okay.
all of this content is actually encrypted in the cloud, and then whoever decides to join the room, our platform distributes to all the audiences.
Okay. Can you talk about any of the challenges in that distribution of the content? Especially if you've got detailed, BIM drawings or models. The weight of those things can get extremely heavy.
Oh yeah. One of the biggest challenges in VR today is how do you get all that information into something that's easily scalable and distributable, right? So a little bit of context is the BIM files for this, I think we're in the realm of about 15 gigabytes. And so shipping a 15 gig file around is no small task. And so there was a lot of work done to actually optimize those BIM files down into something that runs at 90 frames per second on a HTC Vive.
Mm-hmm.
Rumera, release. So that concludes this part of the tour. One thing I wanted to show you real quick is the after. So it's one thing to see it in VR. The question is, does that actually help you when it comes to the real store? And so this is actual footage of the actual store, so you can kind of compare and reference. There were some design changes that happened between the model completion and the store, so you'll see some of those there. We also didn't do a lot of the merchandising because of just the number of polygon and triangles and complexity that added. But you can see that walking through the store for real, so the feedback that the teams that actually worked on the VR project gave us is we felt like we had already been there. So that was a great testament, I think, to the power of VR.
Awesome. Well, thanks, Don. You got anything else before we transition over here?
No, any questions, just throw them in the chat, guys.
Awesome.
Yeah, awesome. Bob had one more question. Have you tried to use point clouds for the model?
We have not, but point clouds are actually part of our workflow when we do scanning, but we don't use them specifically for this because point clouds tend to mean that you already have a physical thing that you scanned, whereas here we're actually creating things from scratch.
Yeah, no, that makes sense. Thank you. Mike had a question too. How long did it take to build this model?
This model, so the first iteration was about 2 weeks, and then each successive iteration took about a week or so, spanning over the course of 1.5 years, pre-store construction.
That's awesome. Yeah, for anyone else that has questions for either Nick or Thong, definitely drop them in the chat or in the Ask a Question section. We have another question that came up and said, can you describe what a typical design session would be like? For example, how many people with a headset on at one time?
So it varies, I think, depending on the organization and who's involved. I think for this project, honestly, they had a full room at their headquarters with 2 headsets. And what they would do is cycle a meeting of 20 people, they would cycle everybody through. And then each of these folks would then provide their feedback and there would be a discussion. So there was a virtual element and then also a physical element too. And I think the power is being able to mix the two.
Gotcha. Bob has a follow-up to his question about point clouds and saying, I was looking for the after project model. Do you have anything you want to add to?
I'm not quite sure I 100% understand that question. So maybe we can follow up on more detail later.
Yeah, Bob, why don't you jot down in the chat. I think Bob was looking at question around using point clouds for the after project model, but Bob, maybe if you can add a little bit more detail, that would be awesome. It says point cloud as an A's built.
Oh, I see. To reference. Yeah, that wasn't part of the scope of work for them. So this project was really focused on the design work itself rather than kind of QAing the work that was the construction work. And I think Nick will actually talk more about that.
Yeah. No, the as-built definitely is a thing once you get into the construction space. So I'm going to share my screen really quick, and then we're going to try this whole streaming HoloLens thing and see how that goes. So I'll just pick up where Thong left off. So, once you get through some of that design phase, you kind of think about, where does it go from there? Once Krispy Kreme has, and all these things are going on kind of simultaneously. But what's going to happen when we're like thumbs up? Okay, everything's good to go. And they're going to effectively hand these files off because you want to leverage everything you can kind of in that continuum. So the architects are going to hand over the files. The general contractor ends up effectively owning those files and distributing them to any of the subcontractors. So we think about framing, plumbing, electrical, HVAC. Each of them, might have their own in-house BIM teams. They might be required to provide BIM models for that because, ultimately you want to reduce risk across the board in the construction project. These are extraordinarily complex. And so each of them will potentially build out their own models for each of those. And then when they have what are called coordination meetings across all of these different teams, they basically will bring the model up on the screen. And I'm just going to bring up, I don't have anything too fancy here, but I do have a kind of an open source hospital design. Hospitals are some of the most complex construction projects out there just because of all of the regulations and the complexity of everything that's inside. But each of these are going to have, some sort of design files. So this might be the original, architect rendering. And then we're also going to have, let me see, where did that file go? We're going to have the mechanical, the electrical, plumbing, and let's see, sorry for the delay here. There we go. And so all of these BIM files are a massive part of what actually makes all of these things work, right? So you've got your original application built out in, some combination of, Unity and, Microsoft, depending, if you're building on the HoloLens, you've got your Microsoft stack. But the IFC file, or I'm sorry, the model files are a huge part of that. So you might have, your plumbing, and, Thong mentioned it earlier. One of the biggest challenges of getting files out into the field when we're talking about designing an application, some of the things that you want to be mindful of, early on are going to be like things like, what's the environment? How big is the environment? How big is my model? How detailed is it? So if we think about things like plumbing, one of the biggest challenges in a plumbing file, they build all this stuff out in BIM. But in framing, you have, a bunch of 2x4s that are going to have, 6, 8, or however many sides. In plumbing, things get a whole lot more complicated because you can see what happens with these files is that when you design them in something like Autodesk, Revit, or something like that, you end up with a single, a single pipe here, right? That's a single file. These are massive applications, and they don't, that's not on your HoloLens when you go to actually get it set up. But you can see here, this file has been converted to an IFC file format. And it is tessellated. And so it's a round pipe, but it has to be broken into as many triangles as it needs to be in order to be round. So you can see that this is basically some serious complex geometry. And what happens when you put these files onto something, small like a HoloLens that has, the memory, kind of on the side of your glasses effectively, is it just falls apart. When you have big things like this. So when you're designing applications, whether it's for, VR or AR, the model design, how big is the files that you're looking at? Another one would be how complex are those files that you're looking at? And then what does the streaming actually look like? Performance on any of these things is going to be absolutely huge because it's, the experience falls apart if you don't have good enough performance. So,
yeah, and to add to that real quick, Nick, like BIM files have everything, right? HVAC, plumbing, stuff that's behind the walls, right? And most people who aren't involved in construction aren't used to looking at that. And so depending on your audience, you could be stripping out, gigabytes and gigabytes worth of data.
Absolutely. So what happens is, if you want to, let's say you want a plumbing contractor to come in and make sure that their stuff is right, or you've got, your concrete folks, you want to check some certain things that are going on in here. You're not going to show everything on there all at the same time because it's never going to fit. You might want to have, if you want to see sprinklers, right? It's a matter of like, who's responsible for building the thing? And are they going to bring some, BIM files to the table? So like here we've got, a mechanical where we can go in and we can see exactly where everything's going to be. Now this is excellent for QA, QC on the job site. Now keep in mind that in terms of this continuum, we also talk about all the way down to property management. Now the property managers might be the biggest benefactor of these design files. So you're in the building, somebody can navigate that entire building and tell you exactly what is on the inside of all of those walls. They don't have to, chop away to find the electrical. So as this ecosystem keeps building, as BIM continues to proliferate, as AR starts to move more and more onto construction sites, the value of these BIM files just continues to grow in its value to everybody along that whole chain. In terms of, I'm going to bring up and see how we can do here on the actual AR side of things. So if you look at something like this, right, you've got mechanical, we went through kind of the architectural side. I'm going to try to pull up an application here now, and I'm streaming through a browser here. So this, you'll have to bear with me to see if this works. I'm going to try to darken here to see if it'll show a little better. So I'm going to do a live preview and hope that it works. Actually, I'm going to refresh. Hey.
Hey, there we go.
All right. Okay, so right now I'm just going to pull up this menu. There's a few apps out there that do the application or pulling architectural models in there. Spectar is one that I have worked on, and I think they actually do a really good job of showing the examples of some of these projects. So they've got a demo here that is let's see here. So now I mentioned you've got these different layers, right? So you can do everything from furniture. They've got electrical, fire protection, framing. And so now if you've got, you have these menus that follow you around. One of the design considerations when you're designing an application, especially if you're doing it on a construction site, is you want to make sure that safety is paramount. That is definitely a massive consideration. So when we talk about that, definitely something very important depending on what industry you're in. So what's happening now is it's basically looking at my room and building, using computer vision to, build out what it looks like. And I'm going to place this exactly in the right location. In construction, they build these buildings off of what's called a project base point. And everything in that building is going to be built off of that. So now you can see what I see in front of me is now all of the framing. So if I wanted to do QC on this project, if I'm a foreman and coming through and I want to make sure that things are in the right place, I'm going to bring this to the job site, and I'm going to be able to spot any errors, right? Did somebody put something 6 inches off here, or can I add another layer and see that up here there's going to be a problem, because whether it's a soffit or an opening for an HVAC, maybe that top bar there is going to be too low. And that kind of stuff happens in construction all the time. So you can imagine the benefit of being able to have something like this. Let's see if I can pull up another different layer here really quick.
And you guys on the stream are seeing it running at like 5 frames a second, so it's a little bit choppy, but what Nick is seeing obviously is running very smoothly. I think just commenting on that though, and you guys chattered a little bit about that before, is there's a lot of, I think, improvements as AR and VR mature in terms of the spectator experience. How do you make sure that people watching get a rich experience and don't get motion sickness just from watching the screen? I think there's still a lot of improvement needed to be done there.
So you can see, like in this, I think what this is showing is where the fire alarms are. And in construction projects, something as simple as is the fire alarm there? If you think about things like ADA accessibility, there's a lot of those types of construction projects that you would imagine if somebody's not ADA compliant, they might have to come in and effectively just rebuild an entire floor because all of the bathrooms in that floor are not ADA compliant. So there's a whole lot of implications, and reasons for why this type of stuff is important to make sure that you're getting it correct. And you can see right now they do this stuff with 2 dimensions, right? So they have a 2-dimensional plan in front of them. Whereas if I can walk through this job site and determine whether or not, that fire alarm pole is there, or whether my mechanical is going to, bang into the plumbing or something like that, there's a ton of value in being able to see, those systems together. And you can also imagine then once you have the property management side of things, that you would be able to further walk through and do redesigns, or understand where there's a plumbing problem, or pressure from an HVAC system or something like that. So that's just a little bit through. You can kind of imagine from there being able to see all of these different applications for construction. You can also look at the same thing and kind of see it through the lens of how it's going to continue to grow and impact from, manufacturing. So if you build a lot of these products, I mentioned the Apple Watch, or, something along those lines, they're building all that stuff. Those 3D assets are being created somewhere along the chain. And if we can continue to build out a lot of the infrastructure so that upfront architects are handing over the files to the right group, thereafter, then you get some much more kind of economy of scale into this becoming more and more used over time in front of us. So if we think about AR on our phones, that's kind of a bridge into AR headsets. And there's a ton of new stuff going on in terms of, folks building out, heads-up displays like the HoloLens, and then kind of the continuation of, these VR applications. Airlines are using them all the time, and they're continuing to expand, their experience for training purposes. And so there's just tons of applications. So I'll kind of stop it at that, and we can hit to some general questions. And then if nothing else, we can certainly talk more. There's lots of additional stuff in here. So why don't we take some questions?
Yeah, well, that was awesome. There's a lot of chatter in the chat right now. I think I'm actually going to start with Greg. Greg had a question for you, Nick. He said, one limitation of AR is the availability of suitable goggles or glasses for HUD or movable palettes. What's happening in the hardware realm where a user trains using AR as they, for example, repair a machine on site with visual overlays of procedural tasks? And what's the future for goggles working on mobile devices?
So I guess there's a couple of answers for that. If we think about, my experience with on the AR hardware side of things has largely been around the HoloLens. So the HoloLens 2 is a massive improvement on the HoloLens 1. And I would say that, a lot of Microsoft's approach to this whole thing is to try to own a lot of the distribution and the communication. So they've got, like their remote services, the ability for, a trainer in one state to be able to connect to somebody who's got to put something together in another state, and they can kind of co-work through that. There's an application called Scope AR that does a really good job of step-by-step applications, and anybody with a HoloLens or AR device can go and check this out. I think that, the best I've seen so far is the HoloLens, but I know that there's a lot of companies getting into this hardware space. A bunch of them are probably going to continue to be more industry specific. There was one that was built and then kind of collapsed called Daiquiri, specifically for construction. But I think it's just all, it's a step in the process for more of these companies to be able to actually have things like, I think it's just an evolving system. Construction is a challenge because the model is going to move on you. So when you walk 10 feet, the model moves. Massive limitation because it's not, within an eighth of an inch accuracy. So I think right now with where we're at, can you build, could one of us learn how to build a Boeing jet engine tomorrow? Might take some time, but I think we're getting there.
Nice. Thong, I'm actually going to go back to you. In the chat earlier, Mike was mentioning a question around, is the model process different for VR model versus an AR model? And I know we've had a little bit of chat you follow up on that, but is there anything you want to add to that?
Yeah, Marty actually gave a good answer to that in the chat. At the end of the day, a 3D model is a 3D model, but the context you're using it in is different. And it goes back to the discussion of AR versus VR, or the spectrum of AR to VR, right? In one case, you are in that world and you can't see outside, and in the other case, you can see what's beyond. The foundation is similar, but the context in which you use those models is different. So for instance, if you look at the models that Nick had, he had the framing and then everything else was stripped out. And what you saw was the real world. Whereas in the models that I was working with, the goal was total encompassing of the environment, right? You wanted to be fully immersed in that full environment. So again, the use cases are different. And I think it depends on what you're using it for.
Yeah, and I'm actually going to read Martin's for anyone that's just listening in auditorily, because it's really good. And said the creation of the 3D models can be done in a ton of different ways and using different applications. The process is essentially the same. That said, there are many very different requirements and considerations. You'll need to create a background/environment for VR, but not for AR, for instance. Additionally, there are very different build targets and APIs for your final application. So thank you, Martin, for adding that in there.
And I want to add on to that really quick, because in the construction space, the part of the challenge is that there are so many applications to build all those things, and there is really no set standard for how these files are consumed or used. So, there's IFC files. IFC is a standard. It's actually better, more advanced in Europe than it is here. But trying to get all of these files. So, take US Bank Stadium, right? They had a general, and that general had the architect files, and then they asked all their subs to go out and build all those files. And they might have built them in 10 different applications. And you want to get all of those files into a single place so that you can get them all together. That is honestly the biggest challenge technically, is how do you not only, how do you get all this stuff on a single headset, but how do you get all of the files to talk to each other? Because there are so many different ways of building things just in construction. There's so many of them. And so I think what's going to happen over time, whether it's Autodesk or Unity, at some point, somebody is going to build out a really solid architecture for what I'll call kind of an atomic system around objects, where you can effectively stream, these 3D elements down to headsets. But I think we're a ways out from that. But that's definitely one of the biggest challenges, is that there's just so many different versions of 3D models.
Yeah, to add to that too, we've been focused on the physical aspect. Something that was interesting in the projects that I've worked on is, what about the digital side, right? It's not just about the walls and the ceiling and the lights. It's about all the digital experiences that are in the store. And once you add those, how does that impact the overall consumer experience? So I think, again, to Nick's point, how do you integrate all of these things into one place, but while managing that complexity? And I think that'll be a long-standing challenge for this whole industry.
Absolutely.
Yeah. We did have another question come up from Mike just now. He wants to know, is it possible to build an AR model of a 2-story machine that can be obscured at the floor so that the customer can see what the machine would look like both above and below ground, or would it be better to have 2 separate models?
So this part's interesting, and because if you think about the performance and the streaming and all of that stuff, generally what has to be done is you either have to break the model up depending on how big it is and complex it is, or you have to find a way to I think in any event you're going to find a way to cut up the model or have to cut up the model a lot of times until they kind of get this, streaming atomic object thing going. But you can also limit things like visibility. So there's the download. How long does it take for this model to download to my headset? And then there's the actual RAM on the device for how much can I actually show anything there. So, you can take a single model and program the system to know that you're going from floor to floor. But generally speaking, you're going to have to cut that model up just because of the number of polygons that are on there. And that's another thing that, it's just another one of the challenges of AR headsets specifically.
A technique that I would recommend is progressive layering. You find this in BIM files, but the challenge is always how do you propagate that to the end experience? And it sounds like with your use cases, right, you could do progressive reveals where maybe there's a switch you flip, right? And then it shows the bottom, so you can actually change the experience that way.
Right. Yeah. Our tiling is kind of, similar in that sense, where I walk through a building and it's going to load, on this grid system a little bit here. And then I walk 10 feet and then it's going to load the next part of the grid.
It's always fun to set those expectations, right, with clients where they're like, I want to see everything. And you're like, that can't handle everything. So let's make some choices.
It's very difficult because people go, wow, I can, see a spaceship. Why can't I see my stuff perfectly like that? And you're like, oh, it doesn't really work that way.
Why can't you fit, a 250 million polygon Krispy Kreme store in a VR headset? Why? Don't know.
Exactly.
All right. We are coming close to time. We have 4 minutes left, so drop any of your last minute questions into the chat. Greg has one. What's the level of interactivity of the models? So far, I've seen fairly simple animations. Can those at least be stopped and started by user?
I can comment on this. I didn't show you guys this, but we actually had the kiosks running at a certain point. And so we had pulled in all of their digital prototypes so you could actually tap on the screen. And so as their agencies were working on this, those concepts were actually in Envision and feeding into the VR model in real time, which is pretty cool. Lighting, modulation of lighting, animation, you can do all that stuff. The big challenge that we run into is cost, right? So what level of interaction you need has an exponential cost factor. And what's really the value of being able to do that interaction? And for the design stuff, right? Like people only wanted to go so far because the cost to really make it realistic just kept going up exponentially.
And really quick to just kind of round that out with one last thought is, the level of interaction in VR and AR is that keep an eye on that, because that is going to be really interesting and really fun. The way that they're advancing, Facebook has a bracelet now that's going to be kind of determining what your muscles are doing for your fingers and interactions. So, it's the interactions piece of AR and VR, I think over the next 5 to 10 years is going to be super interesting.
Yeah, for sure. But interaction with donuts was free, so we did that for fun.
Martin said, anything's possible with enough money and dev time, right?
That's right.
All right. So we are coming close to time. Thank you, Nick. Thank you, Thong. And is there anything that you two want to plug?
It sounds like this audience is involved with a lot of projects and work. You guys should feel free to reach out to Nick or I with questions. We are in this space thinking about it all the time, and we're happy to help.
Yeah, absolutely. We just want to continue to be part of the community and get everybody, help get folks more into this. And it's really great to see that everybody, is pretty engaged with this. So it's awesome.
Fantastic. Well, we'll have both of them drop in the chat wherever you all want to be contacted, whether that is the socials or email. But huge thanks to everyone else that tuned in. This is awesome. Great topic. I loved how interactive it was. So we are definitely going to be keeping these going every 2 weeks, and we look forward to seeing you around. Thanks, everyone.
Thanks, everybody.
Thanks, everyone. Take care.